Hey guys, AP here, and today we are going to be continuing our tutorial series for LWJGL Library 3, and today is tutorial 17, and we are going to be adding loaded, more complex 3D models. Now, I said I was going to be using async, but async is way more complicated because it has built-in animation support, which we don't need right now, and it also has scenes, which we also don't need right now. So we're just going to be adding simple OBJ loading. So yeah, let's get started. So the first thing we need to do is we need to create a new class, which I'm going to get out of here. And we're going to put it in, we're going to put it in the IO, and we're going to call this loader. So class, we're going to call this loader. And so in loader, we're going to have the image. We're going to take, instead of using load image in the actual image class, we can just move this into the loader, so it makes more sense because you load images in loader, as you can see. So now we can just put that in there, and it should be good, no errors, but there should be errors anywhere else. We're just going to delete this, get rid of all those unused. And then in the window, the error is that it doesn't have the same class. So when it says image.loadImage, just change image.loader. And do the same here. So when you save it, it should be saved, and then in the material, once again, do the same thing. And then we can just import it. And yeah. So now there's no more errors. Now we can actually get started in loading, so we don't need this or this or this. So now that we got loader, we need to actually create a function that loads models. So I'm going to show you this because I had no idea if I could remember this, and I don't have any things to help me remember it. So I'm going to get the help from our Lord and Savior Matrix. Anyways. So I'm going to use his way of doing OBJ loading, and then later on when we get into more complicated like animations and all that, we can just use async instead of what technique we're using now. So the next thing we need to do is we need to create a new package, and then in this package we are going to call this OBJ for obviously OBJ loading. And in here, we need to create model data. So model data. And this class will hold all the information for the textured model, including some more information that just helps it with optimization. So the first thing we need to do is just take all this and there we go. So yeah, so I'm going to show you what each one does. So it has a float of vertices, float array of texture coordinates, and float array of normals, which is just a basic thing except normals, which is going to be added on. And this is used, and normals are used for lighting, which will probably be the next tutorial. And we also have indices. But furthest point is pretty new, and that's one of the optimization features. So we won't worry about that until we get into those. So obviously model data, it just holds all of the vertices, texture coordinates, and normals in one thing. And this is what happens when you return a OBJ loader. So yeah. And so now we need to actually get the vertex, which is just one part of this, which is one point in the model. So if we look at our cube again, let's run that. If we load our cube, this corner right here, this is a vertex, and it has no normal, but it has a texture coordinates of, if you're looking at this one, it has 1, 1. If you look at this one, it's 0 or 1, 0, and if you look at this one, it's 0, 0. So it has 3 different texture coordinates, and it has no normals, and so what a vertex does is it basically sorts it all and makes it more optimized to where it can store all the texture coordinates in an array, the position in an array, and the normal, which we're going to be adding today, in an array. So yeah. So if we go to vertex, we actually need to create a class. So class vertex. So in here, in this vertex, we're just going to do another copy and paste. Don't worry, the code will be in the description. I'll have to explain it. So this one is a bit more beefy than usual. It has a no index, which means if there's no texture coordinate or no normal normal, then it'll just have no index, which is going to be -1. So by default, it's going to have no texture coordinate and no normal. And then if there's another vertex just like it, aka if there's like two planes on each other, like if we have a face and then another face in the same exact location, it's going to have the duplicate vertex as itself, basically. And so index is just like what index is on for either of these, and then length is obviously if you want to get how long the vertex is. And so going through here, you have some gets and sets, but is set, meaning that it's not like a not invalid vertex, meaning that it has a texture index, which means it has a texture coordinate, and it has a normal coordinate, which it should, and then has same texture and normal, which means that if it has the same texture and normal, which basically say you have that one and that one, it'll return true or false. Set, get, it's just normal get, and then again set. And so now we can actually explain all these optimizations when we get our last class, the OBJ loader. Excuse me. OBJ loader. So now we just copy this huge chunk. And so we're going to paste that, but then paste it in here. Okay, so now that we have this, we should be able to finally get OBJs to load. So what should happen is we have ourselves a load OBJ, which returns model data, which once again is just a class where it holds all the vertices, texture coordinates, and normals. And so now if we go through file reader, it makes a file reader, it makes a new file, and the resources, and then we have to make a new folder called models, and then whatever the file name is. And so it makes make a new file reader. If it doesn't, error file not found, obviously to make sure that there is a file. And then buffered reader equals new buffered reader ISR, which means that it can actually read the file, string line, what is the current line, and then it actually creates all of the information for the model, which is vertices, textures, normals, and indices. And so what should happen is it should go through all the lines, and it should split them up into 4 categories, which if we open up an OBJ model, which should be down here, you can see. So the first one is going to be V, which stands for vertex, and it's going to be one of these first ones. So the V is going to have, first of all, the first one, and then it's going to have 3 points, which is, this is going to be the X, this is going to be the Y, and this is going to be the Z. And this is from the model's origin, so, and that's where all the transformations are going to be held. And so, when we do this, it splits it into an array, which basically makes the first one, or makes it into a 4 long array, which has the V, the X, the Y, and the Z. And then it gets rid of the V, and it actually sets the vertex as whatever the current line is. And so in this new vertex, it creates a vertex, this type of vertex, and it adds it to the arrays that we made it up here. And so if it's VT, aka texture coordinates, which might take a bit of scrolling to get to. That's V. Is there actually no VT? I don't think there is a VT. Or if there is, there's a very small one. Okay, let me get to there. Okay, yeah, VT. So, VT is basically the texture coordinates, the top left and the top right. For this one, there wouldn't be any because this dragon model doesn't use any textures. You can just use any texture you want. So I just have a plain white texture. But as you can see, it goes from top left, to what is it? Top right, and then it goes to bottom right. So it just basically makes a simple triangle texture. And so now it does the same thing here, splits it into a 3-long array, gets rid of the first one, and then adds it to the texture. And the VN is for normals, as you can see here. And of course, like I said, this is for lighting. And what these normals, these values mean is it signifies the direction of the facing. So once I'll show you in this cube. So if we look at this cube, if this were to have normals, the normal would be, if for the top face, it would be just going straight up. So it would just be going like from the middle of the stickman to where I am. And for here, it'd be going from where I am to stick figure, stick figure, stick figure, and stick figure. So this, and that's how normals work. It's basically, where is the polygon facing? And so, yeah. So, yeah. So, and then what F stands for, it stands for face. So, it should, in the correct OBJ loading, it should be after all of these. So, let me grab this. Yeah. So, these faces should be after all of the vertexes, vertex, texture, coordinates, and normals. So, then it goes into a new one where it starts to sort all these vertices, texture coordinates, and normals. So the first things it does is it gets the first vertex, which is whatever this stands for. So let's just take this one. So it starts off with this one. So it has 4,774 for the vertex, 1 for the texture coordinate, and 40,774 for the normal. And so using this, we can actually sort them into a correct array. So it gets them, it splits them by these little dashes right here. And yeah, so now we can actually split them. So current line 1 is dot split, so it gets the vertex. Current line 2, it splits it by and it splits it using this. And of course, we have to call a function called process vertex. So it takes in the vertex, the vertices, and the indices. And so with this, int index equals integer.parseInt, and this gets the index for the vertices, and then it gets that right here, and then it gets the index for the texture, and then it gets the index for the normal. And if current vertex is set like we did in the vertex, that means if it's ever been changed, then if it's not ever been changed, then actually change it and then add it to the indices. And then else deal with already processed vertex, and then that's another one. So deal with already processed, that's down here. So new normal, and it makes all these. If previous vertex has same texture normal, so if it's already been processed, then add the previous vertex and you just leave the already processed vertex alone. You just get rid of it. Else, then it creates the vertex and it does a recursion loop, where it keeps going until another vertex is found. So if you need more information, of course, go to the matrix. This video will be in the description. Everything will be in the description. And yeah, so if we go back up here, once we get done processing all three of these, it stops a reader.close, and then it removes unused vertices. AKA, it goes through all the vertices in the list, and if the vertice is not changed, then it gets rid of it. So then it creates a vertices array, textures array, normals array. It creates the furthest point, and it creates an indices array, and then it returns a model data object like we created here. And so there is another one, convert indices list array. It just converts a list into a normal int array, and same for the. And this one, convert data to arrays. It just it converts all these vertices and textures normals into the correct array. So yeah, and then remove just of course gets rid of all the vertices, and yeah, so we should now be able to go to loader and actually add all this. So public void or static textured model load model, if I can actually type, load model, and it should take in two strings, so string obj path and then string texture path. And so now if we look at this, we can actually say model data is equal to what is it, obj loader dot load obj, and then whatever our path was. So once this loads, you can put obj path in. Obj path. Let's load today. So now import all the classes. Now we need to actually create a texture model. So textured model, a model is equal to new textured model, and in our textured model class, where is it? It's in rendering models. Wrong one. This is so in our models. So in our models class, we should go to texture model, and we should actually add a way to store normals. So we can do it after our texture coordinates. So float array normals, and yeah. And so we can, in here, before we do this, we can just say normal buffer ID. Normal, if I can get it all, normals, if it can load buffer ID, it should be stored in the second one. It has a length of 3, and it takes in the normals. And we should also create that up here, normals buffer ID. And so yeah, now it can store normals. You may get an error in your main, but we can fix that after we get our loader. So going back to the loader, we need to do data.get vertices, data.get texture chords, data.get normals, and then data.get indices. And at the end of that, we just put in our texture path. And we should be able to return that. So instead, we can actually do just return and then new texture model. So that should be it for this. So now if we go to our main class, of course there's going to be an error in this huge thing. Not to worry, we can just get rid of it. So if we just do this, oh, and we do that, in here we can say loader.load model, and then our obj path, which is going to be dragon.obj, dragon.obj. It needs to be in strings. Dragon.obj. And then in the texture path, we need to have our texture, which is just going to be white.png, because once again, this model doesn't use any textures. So now if we go here, we should have we can just fill that in by doing GL delete buffers normals buffer ID. So now, after all this is probably one of the most confusing tutorials I've ever made, and that is no joke. We need to go to our resources, create a new folder called models. So, folder, no package. And this is going to be called models. And then we could just put whatever models in. I'm just going to take in what dragon model we had, put it in there. Always save. Now if we go to textures, I don't have that anymore. So I guess we could just use our default texture as it is. Wait, where's my, there it is. So after all this, we should have a weirdly looking dragon, but you can obviously tell it's a dragon. So yeah, let's run. Let this load a bit. And here we go, if I can back up. And here we go, we have ourselves a dragon. Of course it's weirdly colored because it's not supposed to use textures, but we don't have a substitute for that yet. So yeah, so now you can see that you should have a dragon. If you don't, that's probably because this is one of the worst tutorials I have ever made, because I did not actually teach you anything. I just say, go look at another video, and I just showed you what I did. So yeah. Speaking of go look at the other video, please go look at the other video. I did not explain this to my best ability. I will show you, I'll not show you, I will link it in the description, and Thin Matrix, which is an awesome guy, as I said in my live stream, that he can explain it, because he made it this way, or at least he knows it way better than I do. So, yeah. Anyways, code is in the description for the copying and pasting. Don't worry, I did explain it. So all the people who think that I just copied and pasted and just said that's a tutorial, no. I tried to explain it. And so, yeah. Anyways, that'll be it for this episode. I hope you guys enjoyed it. Once again, one of my worst tutorials, but I just needed to get it over with because ASIP's way too complicated for just loading something like this. So anyways, that'll be it. Like I said, I'll see you guys later. Oh, if you have any questions, leave it in the comments or join my Discord, which is also in the description. So anyways, bye.